Hi, Assalamualaikum. My name is Nur Ali Adila binti Hamrizal and my matric number is 2230171.
Hello, my name is Nur Saadah binti Aidi and my matrix number is 2230168.
Hello, my name is Nur Suzia Noordin. My matric number 2230170.
Okay, introduction. Here we have three objectives that can learn from this wiring lab. Firstly, have the ability to effectively utilize electrical measurement tools. Second, we acquire the necessary knowledge and skills in electric circuit design, connection and installation. And lastly, we have a comprehensive understanding of safety aspect when working in a wiring lab. That's all. Next, we have many things that can be related about safety awareness. But here, I will only talk about PPE, which is personal protective equipment. We have 4 PPE, which are insulated glove, clothing, safety boot, and head. Firstly, we need to wear insulated glove to avoid any electrical shock, as they are certified for specific voltage. Second, we need to avoid synthetic material that can melt and stick to skin. Third, we must wear safety boots to prevent any heavy object falling or something drops from a head. And lastly, wear a hat to protect our head from different types of hazard.
I want to talk about design and planning. Firstly, hands-on 1, distribution box. Material and equipment we use is 6 ampere MCB, 16 ampere MCB, 20 ampere MCB, main switch, RCCB, 4.0 mm wire, 4-way copper busbar, tools box. Discussion of material use. In this experiment, we are using 4.0 mm wire based on ST guideline. Connect to the live and neutral wire between main switch, RCCB and MCB. Then connect earth wire to ground terminal. Function of RCCB is to identify and trip electrical leg current, ensuring safety against indirect connect related electric shock. For MCB, we used to locate and trip electrical leg currents, protecting against electric shock caused by indirect contact, and for earth wire act as a safe part for electric to run in the event a short current. On hands-on 1, 2-way switch. Material and equipment we use is 6 ampere MCB, lamp holder, 1.5 mm wire, 2-way switch, PVC switch base, plumber plate, toolbox and sealing rose. Discussion of material we use is for wiring of 2 switch. We use 1.5 mm wire. This switch connect to 6 ampere MCB because we use it for lighting circuit. This means it can effectively protect this specifically electrical device from overloading and short circuit, ensuring the safe and reliable operation. We also make a loop between switch 1 and switch 2 to make sure there are extra part if one of switch stop working. This loop keep network connect going and decrease timeout if there any hardware issue. This loop help to maintain network connectivity and minimize downtime in the event of hardware failure. Hands-on 2, conducting wiring. Material and equipment we use is 2.5 mm wire, 20 ampere MCB, 60 ampere MCB, 13 ampere switch circuit outlet, PVC switch base, PVC electric wiring conduit, tools box. Discussion of material we use is on hands-on 2. There are 2 types of wiring socket, namely ring circuit, radial circuit. radial circuit has two sockets. The wiring is connected from at 16 MCB to one of the socket and goes through a loop to the other socket to generate electric to the other socket. For the ring circuit, we use 4 sockets. The ring circuit is more or less the same as the radial circuit. The only difference is that the wiring done from 20 ampere MCB to the socket has 2 wiring, then loop to the other two socket. We use 2.5 mm wire for ring and radial circuit because it is the standard size recommended for this type of circuit to handle the electrical load and current requirement. On hands-on 3, mini tucking, material and equipment we use is 6 ampere MCB, 1.5 mm wire, PVC fan regulator base, ceiling fan electronic regulator, PVC electrical wire ceiling, one-way switch, PVC switch base, fluorescent lamp, toolbox. Discussion of material we use for hands-on 3. We do the wiring for the fan and light using mini tracking wire method. We make a loop between the fan and switch the light using the live wire from the 6 ampere MCB. Then the neutral and earth wire from the distribution box is connected directly to the fan. While for the lamp, we do a loop again to connect the neutral and earth wire in the lamp. The switch we use for fan and light is a one-way switch. The wiring we use only 6 ampere because we already know like fan, light and air conditioner. We use 1.5 mm based on ST guideline because it is the application size for the amount of current that we be following through the wires.
Hands-on 1, distribution box.
On hands
Final results for hands-on 1, distribution box installation and surface wiring, one-way switch and two-way switch. First of all, we got a value of set of multimeter is 0.3 ohm. And then based on continuity test using multimeter, for number 1, between point N of dB and point N of the lamp holder, we got 0.3 ohm. Number 2, between point L of dB and point L of the lamp holder with one of two-way switch in the on position, we got OL. Number 3, between point L of dB and point L of the lamp holder with both two-way switch in the on position, we got 0.3 ohm. And last, between point L of dB and point L of the lamp holder with both two-way switch in the off position, we got 0.3 ohm. Okay, final result for hands-on 2, conduit wiring and ring and radial circuit. Okay, based on continuity test using multimeter, we start from radial circuit first. Okay, number 1, between point E of dB and point E of each socket outlet, we got 0.4 ohm. Number 2, between point N of dB and point N of each socket outlet, we got 0.5 ohm. Number 3, between point L of dB and point L of first radial socket outlet, when it is switch is on, we got a number which is 0.5 ohm. But for number 4, between point L of dB and point L of first radial socket outlet, when its switch is off, we got OL, open loop. Then number 5, between point L of dB and point L of second radial socket outlet, when the switch of both radial socket outlet is on, we also got 0.5 ohm. Number 6, we got OL, which is between point L of dB and point L of second radial socket outlet, when the switch of first radial socket outlet is on, but the switch second radial socket outlet is off, we got OL. That's for radial circuit. Okay, now go to ring circuit. Number 1, between point E of DB and point E of each ring, if of each ring circuit socket outlet, we got 0.4 ohm. Number 2, between point N of DB and point N of each point of each ring circuit socket outlet, 0.4 ohm. Number 3, between point L of DB and point L of first ring circuit socket outlet, when its switch is on, we got 0.3 ohm. Number 4, between point L of DB and point L of first ring circuit socket outlet, when its switch is off, we got OL. Number 5, we got the value 0.4 ohm, which is between point L of DB and point L of second ring circuit socket outlet, when its switch is on, we got the value 0.4 ohm. And number 6, between point L of DB and point L of second ring circuit socket outlet, when its switch is off, we got OL. So for the conclusion of hands-on 2, final result of hands-on 2, show that the value for connection of earth and neutral wire in both radial and ring circuit. For hands-on 2, what we can conclude is the continuity test show the value for connection of earth and neutral wire in both radial and ring circuit, because we get the reading value when the switch is on and get OL when the switch is on in the off state for both socket, ring and radial circuit. Likewise, for the ring circuit, we get reading for tak terlibat. Kejap. Okay, last final result for hands-on 3, mini trunking wiring, main circuit and lighting circuit. Okay, from continuity test, number 1, for ceiling fan circuit. Okay, number 1, between point E of DB and point E of ceiling fan connector, we got 0.3 ohm. Between point N of DB and point N of ceiling fans connector, also we got 0.3. And number 3 until number 3, we got between point L of DB and point L of ceiling fan connector, when one-way switch is in the off position, we got OL. Okay, number 4, between point L of DB and point L of ceiling fan connector, when one-way switch is the on position and adjuster of regulator at position 1, we got OL. Okay, for ceiling fan, we got OL from position 1 until position 4, but position 5 we got 0.3, full position 0.5, we got 0.3 ohm. Then for one-way switch, fluorescent lamp circuit, between point N of DB and point N of the lamp, we got 0.3 ohm. Between point L of DB and point L of the lamp with one-way switch in the off position, we got OL. Number 3, between point L of DB and point L of the lamp with one-way switch in the on position, we got 0.5 ohm. Then what I can conclude for this hands-on 3 final result, the connection between the earth wire and the neutral got a reading. For the fan, we get the OL value at position 1 until 4, but get a reading at position 5 when the switch is on. This is because the resistance reading is slightly dependent on the current flowing through the circuit, and if the fan is operating at a lower speed in position 1 to 4, it may not be drawing enough current to register a reading. And for the lamp, we got the reading value when the switch is on and vice versa. That's all.
First is malfunctioning multimeter. Main challenge is we must check whether the multimeter functioning can measure appropriately. So second, we set to the lowest resistance to measure some current in wiring. So second, insecure circuit. Insecure circuit is ensure that the circuit connected correctly and have a current flow in the circuit. So second, comprehend the potential decreases. And last, to avoid electrical shock in the circuit. We must check whether the configuration and the safety of circuit effectively in any laboratory. So in order to avoid that, we must focus and pay attention carefully at the circuit and how to connect or use the electrical in the lab.